oldest science in human history. Thousands of years ago, people were turning their eyes to the sky and wondering what was out there. Today, telescopes peer billions of miles into space, observing events which happened long before our solar system was even born, seeking the answers to very big questions. What are the origins of the universe? How old is it? And are there any signs of life out there? Where have we come from? Where are we going? And are we alone in the universe? Questions don't come much bigger than that. Scientists can't say why the universe was created, but they can answer questions about how and when it all began. Astronomers have been looking through telescopes for nearly 400 years. And now they're looking for even more clues by shooting telescopes way up into space.
Liftoff of the Space Shuttle Endeavour with NASA's newest tracking station in the sky.
But getting up into space is no easy task.
All program Houston.
Isaac Newton himself realized that there was a velocity so fast that if you hurl something into space, it would never come down. That velocity is about 11 kilometers per second. Now that sounds like a fantastic velocity until you realize how big the solar system really is. It would take about 2 months traveling at 11 kilometers per second just to reach Venus, a nearby planet. Perhaps 6 months to reach the planet Mars. Perhaps 8 months to reach the Sun. Now think of the nearest star. The nearest star is trillions of miles away, and it would take perhaps 120,000 years traveling at this fantastic velocity to reach the nearest star. That's how vast the universe really is.
We have been able to send small spacecraft to survey the planets and the Sun, but the nearest star is 5 light years away. That's nearly 30 million miles. If we want pictures of distant objects like that, we still need a good telescope.
4, 3, 2, 1.
The space shuttle wasn't built only to take people into space. It's been used to launch dozens of satellites, carrying instruments to examine the universe. Away from the Earth's atmosphere and pollution, they can get a far clearer view. One of the most valuable has been the Hubble telescope, named after Edwin Hubble, one of the most celebrated astronomers of the 20th century. It took 10 years to build and was launched from the shuttle in 1990. Unfortunately, scientific experiments don't always work right the first time. And when Hubble sent back its first pictures from space, the astronomers were devastated because this is the sort of thing they got. Look at it. It's all blurred. There'd been a tiny miscalculation while they were making the big mirror, and as a result, all the pictures were out of focus. It was a tragedy. Astronauts returned to space in 1993 to install a contact lens to correct the fault. The revitalized telescope gave us amazing views of the universe. It revealed spectacular images of exploding stars and of gas clouds where stars are born. The telescope is the nearest thing we have to a time machine. The deeper it looks into space, the further back in time it sees. Space is so vast that light from those very, very distant stars travels for millions of years before it reaches us, which means that we can't see what they're like now, only what they were like millions of years ago. In 1996, scientists began an experiment called Hubble Deep Field to peer into the most distant regions of the universe. They maneuvered the Hubble telescope to focus on what looked like an empty part of space. As each day passed, the telescope produced images of more and more distant galaxies, further and further back in time. Finally, on day 10, it showed the universe as it had been in its infancy 14 billion years ago, revealing galaxies that had formed a few hundred million years after its creation. The Hubble telescope was looking at a fantastically narrow little bit of sky. Look at this 50p piece. Can you see the Queen's head? Can you see the Queen's eye? It's absolutely tiny. And if I hold that 50p up at arm's length, then the area of sky that the telescope was looking at is about the same as the area of the Queen's eye, just a tiny, tiny hole in the night sky. And in that tiny hole, they could see dozens of galaxies. And in every one of those galaxies, millions of stars. And the point is, it wouldn't have mattered where they had pointed this telescope, they would still have seen millions and millions of stars. It makes us feel kind of insignificant, doesn't it? But these pictures were much more than snapshots of outer space. They provided evidence to support what had once been one of the most radical theories about the universe. The theory came from the man who gave his name to this amazing telescope, Edwin Hubble.
Edwin Hubble, one of the greatest astronomers of the age, was a very strange chap. First of all, he came from Missouri, from the backwash of modern society. However, he was very ambitious.
Edwin Hubble was one of those infuriating people who are good at everything. Athletic and brainy, he came top of his class, though he was 2 years younger than everyone else. And he won scholarships to the universities of Chicago and Oxford.
And at that point, he's dazzled by upper-class British society, and he begins to put on the affectations of an Oxford don. He begins to put on golfing trousers and tweeds, and he begins to put on a British accent. So here we have this young gentleman of very humble means putting on the affectations of upper-class British society.
But when it came to choosing a career, Edwin fell out with his father.
His parents wanted him to become a lawyer and make money. However, he had this childhood passion with the stars, and that propelled him on the way to become the greatest astronomer since perhaps the time of Kepler and Galileo.
To satisfy his parents, Hubble did study law at university, but he spent his spare time studying the stars in the observatory and made astronomy his career.
Let me know when we get close to the right coordinates.
Okay, steady, 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 stop.
Okay.
This is the sort of telescope that a lot of astronomers used in the 1920s. It's an 8-inch refractor. It's got lenses in it, and it's powerful enough to see the sun or a star the size of our sun from a distance of about 100 light years. Now, do you think that Hubble was wise to take up astronomy rather than the law?
Oh yes, very much so. I mean, I'm sure he would have made a lot more money doing law, but astronomy is much more fun.
But it wasn't just fun that got Hubble interested. He wanted to find the answer to the big question all astronomers were then asking: how large is the universe? To do this, he needed to get his hands on the biggest telescope he could find. He got himself a job at Mount Wilson Observatory in California. Its brand new 100-inch reflector telescope could reveal details about stars which no one had guessed at before. Hubble's main interest was in nebulae. Nebulae is the Latin word for clouds, and that's what most astronomers thought they were, clouds of gas out there in the Milky Way. These early photographs looked grainy and crude, but they were the best that could be achieved with the technology of the time. And it could be hard work. Even though Mount Wilson is in California, the observatory is on top of a mountain and it can get very cold. And that wasn't the only problem. Quite apart from the perishing cold, taking photographs of distant stars was a really tricky business. First of all, you had to take a photographic plate like this one, a great heavy thing, mount it in the back of the telescope, line up the telescope precisely on the tiny patch of sky you wanted, then take out the dark slide like this to expose the film to the light coming in, and then track your star for hours and hours. Because if you didn't keep exact track of it, your picture would be all fuzzy, and you'd have to start all over again. But when the mighty 100-inch telescope was pointed at the nebulae, it became plain that they were not just gas, but clouds of stars, millions of them. And this set off another debate. Were these clouds of stars part of our galaxy, or were they separate galaxies, far, far beyond the Milky Way? Hubble photographed more than 500 nebulae. He saw they came in different shapes, spirals and ellipses. They seemed big enough to be called galaxies, but how far away were they? Were they part of the Milky Way, or out there on their own? Most astronomers firmly believed that the Milky Way was the only galaxy. They were led by Harlow Shapley of Harvard University.
On one hand, we had the astronomer Harlow Shapley, a Harvard astronomer, who said that the Milky Way galaxy is all there is. Think about it. In the night sky, you see this swath of light cutting across the sky called the Milky Way. And this Harvard astronomer says, that's the universe. That's all there is. The universe is nothing but the Milky Way galaxy. Well, here comes Edwin Hubble, who tries to settle the question. How big is the universe anyway?
Shapley and his colleagues didn't like Hubble. They mocked his English accent and thought he was a bit of a snob. But the rivalry spurred Hubble on. For night after night, he peered out through his telescope and took photographs of one of the largest nebulae in the constellation of Andromeda. When he compared the photographs, he noticed something remarkable. And this is one of the very photographs that Hubble himself took on the 6th of October 1923. He wrote the date on it. If you look, it's a negative. Normally when you look up, you see the stars bright against a black sky, but they're rather hard to pinpoint. And if you print them this way around, a negative, it's easier to pinpoint the stars, and so they're black against a white background. But what really excited him was this up here. Between these two black lines, there's a tiny dot, and he's marked it VAR with an exclamation mark. VAR means variable star. The reason he was excited is that variable stars are pulsating balls of gas that go bright, dim, with a regular cycle. And although he had no means of finding out how far away these nebulae were, he did have a method of finding out the distance to a variable star. The maths is complicated. Astronomers spend more time doing sums than looking at the stars. But in brief, once Hubble had found this variable star and had studied how bright it was and how long it took to go from bright to dim, he was able to work out how far away it was. And the answer he came up with was 2 million light years. That's something like 40 times further away than anything in the Milky Way. Obviously, it was a totally different part of the universe. It was proof that the universe was far, far bigger than his rivals had claimed. But before he published his findings, Hubble wrote to his rival Shapley to tell him what he had found. He must have been terrified that Shapley would find some fault with his calculations. But when Shapley got the letter, he simply said, "This letter has destroyed my universe." Hubble had shown that the universe was far vaster than anyone had imagined and contained not one but countless galaxies. Tell me, what are all these dishes for?
These dishes pick up radio signals from very distant extragalactic objects outside our own galaxy.
Many modern observatories study distant galaxies by picking up their radio signals. But Hubble didn't have a radio telescope. It was by studying the light from galaxies that he made his next great discovery. Astronomer Mike Hobson explained that the wavelength of the light Hubble saw appeared to have been stretched. Its frequency was shifted towards the red end of the spectrum. This could happen only if the galaxies were travelling away from us.
Every galaxy he looked at had what's called a redshift, a shift to the red, which meant that it was moving away from us. And more importantly, he found that the speed with which they're moving away from us was directly proportional to the distance they were away.
So the ones a long way away were moving very quickly?
Indeed, that's right. And that is known as Hubble's law.
What Hubble found was an expanding universe, one in which all the galaxies, these are meant to be galaxies, not stars, were moving apart from one another. And this idea of an expanding universe was something that most scientists found very hard to accept.
Hubble's ideas were so revolutionary and shocking that many people began to maybe perhaps disbelieve that the universe could be expanding or have an origin. But then here comes Einstein, perhaps the greatest scientist of the age, who comes in and says, yes, this is what my equations actually say.
Einstein had always been puzzled that his calculations seemed to show that the universe must be expanding or contracting. He thought he must have made a mistake. He was delighted when Hubble's observations showed he'd been right all along.
Hubble gave us an entirely new picture of the universe, an expanding universe, a universe where stars and galaxies are moving away from us. But that begs the question, where did the universe come from? Think of a motion picture of an explosion with all the gases moving away. Now run that motion picture backwards. When you run it backwards, you can actually calculate the time at which all these gases came from a single point. And that's what Hubble was inevitably forced to conclude. The fact that there was an origin, a time at which the universe came into being. And with Hubble's calculation, he could even give us a number, the age of the universe itself.
Hubble's idea of an expanding universe suggests that it may have been formed initially in some cataclysmic explosion. And this wonderful telescope here was built specifically to listen to the echoes of that Big Bang. The latest estimates, based on Hubble's original theory, suggest that the Big Bang happened about 15 billion years ago. The universe is absolutely vast. What are the chances that somewhere out there are some intelligent creatures, maybe a bit like us? Well, in our own solar system, it seems unlikely, but recent discoveries suggest that just possibly out there somewhere, there may be intelligent life. If there are any intelligent creatures out there, they're not going to come in spaceships because the distances are just colossal. What's much more likely is that they'll send radio signals to try and communicate. And that's why radio astronomers are listening out with those great huge dishes to try and pick up radio signals from outer space. So far, alas, they haven't heard a thing. But there's a small chance life could be found closer to home. There are now plans to send probes to Jupiter's moon Europa, where underwater volcanoes may be warming the sea, creating suitable conditions for life miles beneath the frozen surface. So keep listening. Maybe one day an alien will call, possibly from a submarine.